Hello, fourth grade. Today we are going to talk about the most distinguished of fourth grade math problems, multi-step operation problems. You have learned so far this year how to add, subtract, multiply, and divide numbers of great value. And today we're going to work on ones that take more than one of those, all in the same question. So go ahead and make this the title of your next page in your math notebook, and when you're all done, unpause, close your notebook, and move on with me. Alright, so as I said, so far this year you've learned the addition algorithm, you've learned the subtraction algorithm. Hopefully you're excellent at both of those. We've learned some multiplication strategies like partial, products, and area model. Depending on when you're seeing this, we may have even started doing some number talk strategies with these. Division, we've learned the area model as well. The partial quotients method. And so we spent a lot of time getting really good at these operations. Hopefully you are getting good at them. And so we're going to work on the most distinguished of problems today, which require you to do more than one of these in the same question. Let's see one. So here's an example. Tough problem. Okay. It says Jason loves tennis. He has 25 cans of tennis balls, and each can has 3 tennis balls in it. Jason plans to play 9 tennis matches this season, and he wants to bring an equal number of his balls to each match. How many can he bring? Whew, okay. So let's analyze what's going on here. So I've got more than one thing happening. So first I have how many tennis balls he has, right? And he has 25 cans of tennis balls, and each can has 3 in it. So that sounds to me like I have repeated addition, right? 3 plus 3 plus 3 plus 3, 25 times. So to me, that kind of each can part makes it sound like I'm going to multiply up here to find out how many tennis balls he has. It sounds like he has 25 times 3 tennis balls. That's what it sounds like to me. But that's not the end of the question. I've also got to figure out how many he can bring to his matches. So he plans to play 9 tennis matches this season, and he wants to bring an equal number to each match. That sounds like making groups to me. I want to take, however many this is, I want to take an equal number. I want to divide them into equal groups to take to his tennis matches this year. So that sounds like division to me. So it sounds like what I'm going to have to do first is figure out how many does he have, and then take that and divide into 9 groups. So it's going to take me 2 steps here. I'm going to have to multiply, then I'm going to have to divide. So let's do it. So first let's find out how many he has. He has 25 times 3 tennis balls. You may be able to do that in your head. I'll go ahead and use a strategy out just in case you can't do it in your head, which is still okay. So I'll use the partial products method here. I'm going to do 3 times 5, that is 15 tennis balls. And then I'm going to go 3 times 20. 3 times 2 is 6. And then 0 from the 20. And all together, 5. Looks like he has 75 tennis balls. And so my next step was to say, okay, well, he's going to take however many he has, which is 75, and we're going to divide those up for each of his 9 tennis matches. I'm going to make 9 equal groups out of that 75. 1, 2, 3, 4, 5, 6, 7, 8, 9, and see how many he can take to each tennis match. So that's division. I think I will use the partial quotients method here. So I'm going to do 75 tennis balls divided by 9 matches. Let's see, 9 times, I like to start with 1, 2, and 5, or 10, 20, and 50, something like that. So I think this is going to be too much. That's 90, so I'll start with 9 times 5 is 45. Subtract those, and that's 30. And then let's see, I think the closest I know is 9 times 3 is 27. And I cannot make any more groups of 9. So it looks like I can make 8 groups of 9, and there are 3 left over. So, I guess my question is, how many can he bring to each match? So, looks to me like he can bring 8 to each of his 9 matches. So he can bring 8 to each match. And let's think through my remainder possibilities here for this other 3. So one possibility is he can just leave these 3 out. So just keep these 3 and use them to practice or something. So bring 8 to each match and leave 3 home. Another possibility is he could bring 1 extra ball to 3 of his matches. So he could bring 9 to 3 matches and 8 to the rest. That would work too. As far as the other strategies make another incomplete group. That would mean make another match, make a 10th match, and just bring 3 to that match. I don't think that really makes sense. If he only has 9 matches in the season, I'm not sure that one makes a whole lot of sense. So, lots there, right? I multiplied, and after I multiplied, I added, and then I divided, and as I divided, I subtracted. So I used every operation in that problem, in that multi-step problem, to get to my answer. So pretty tough. This is a very distinguished question, and if you can think through these and do all the math correctly, you're a very distinguished math 4th grader. Open your math notebook. Let's do one together. Go ahead and pause if you need to write the question down, because it's kind of a long one since it's a multi-step. And then you can unpause when you're ready. Again, you can work this out ahead of me. You can pause and work it out. You can work it out as I work it out. Or you can watch me work it out, then pause and write it down. Any of those is fine on a WeDo. All right, so the Atlanta Braves Stadium can hold 41,119 people. The Atlanta Hawks Arena can hold 21,613 people. There's a stadium in Texas that can hold twice as many as both of these stadiums combined. Woo! It's big. How many people can it hold? Okay, so let's see. I see some words in here I want to talk about. Twice as many. That sounds like a multiplicative comparison to me. And I also see the word combine. Combine means put together, and usually tells me I'm going to do some adding. So the stadium in Texas can hold twice as many as these combined. So that sounds to me like I've got to combine those and then find out what twice as many is. So I'm going to add, and then I'm going to complete my multiplicative comparison for 2 operations. So first thing to do, before I can find out how much the Texas one holds, I need to find out how much these 2 can hold combined. Combined is a key word for add. Combined means put together. So I'm going to use my addition standard algorithm to add these 2 buildings together. So if you combine the Hawks Stadium and the Braves Stadium, I would be able to hold, let's see, 9 plus 3 is 12. That's 2 1s and 1 10. 1, 2, 3 10s. 1 and 6 is 7 hundreds. 2 thousands and 6 10,000s. So together, the Braves and the Hawks buildings can hold 62,732 people. And this stadium in Texas can hold twice as many people. So this times 2 is going to equal the Texas Stadium. There's my multiplicative comparison. So I need to figure out how to multiply that by 2 to find twice as many. Couple possibilities. So we never, in 4th grade, we never practiced using a multiplication strategy on a number this big. You can. I bet you can figure out, if there was no 6, you do know how to do that times 2. And you could make your area model or your partial products. I'll set up an area model. So that's my top, and I'm going to multiply that by 2. So that you would know how to do. So if you wanted to apply this strategy to a number we haven't yet, you would just need to extend your area model and include that 60,000 that I scribbled out. So it'd be a lot of multiplying, but you could definitely do it. Now, if you look at this and say 2 times 60,000, I just don't want to do that. I'm not sure I'm going to get the right number of zeros. That's just more than I'm comfortable with, and I don't want to do that. That's okay, because that's not your only strategy. So if you look at this and you say to yourself, oh man, that's just too scary. I don't want to try to multiply this number up to the 10,000s by 2. 2, I can use a pretty easy old strategy when I multiply 2. I could just use repeated addition, which I think I'm going to do. If you're comfortable multiplying like this, go for it. There's nothing wrong with that, and I encourage you to do it. I'm going to go ahead and do repeated addition. Since I just have to do it times 2, it's not like I have to do it times 30 and add it over and over and over again. I'm just going to take my 62,000 to multiply by 2, so I'm just going to add it one extra time. Because I actually think that might be the easiest way to do this addition. So I think I'll do that. 2 plus 2 is 4. 3 plus 3 is 6. 7 plus 7 is 14. So I'm going to keep 4 hundreds and carry over the other 10 over to the thousands. And that's 5 thousands and 12 10,000s. And believe it or not, there is a stadium in Texas that can hold 125,000 people. It is really big. 125,464 people would be our exact answer. So guys, these are tough, man. These are distinguished questions. You've got to really think through your whole situation, think through what operations you need to do, and think through what order to do them and what strategies to use when you do them. They're seriously distinguished questions. We will practice some more tomorrow. If these were pretty tough and you need to watch this again to get some extra practice, please do, because I want you to come to class tomorrow really ready to tackle 2 more of these at a high level. All right? So after you have done that, I will see you tomorrow.